So in these notes, we're actually going to conduct our first significance test. It's actually going to be about a population proportion. And to get there, it's going to be one of those state, plan, do, conclude problems. So in the plan step, we're going to have to mention something about the conditions. So what are the three conditions when we do a significance test for a population proportion? And then how might they be different from the ones we used when we did a confidence interval for a population proportion? So a significance test means we're going to test some hypotheses. So this would be the null hypothesis, and we're interested in knowing something about a population proportion, which is P. The first condition you definitely know is randomness. That one's not any different. So the data come from a random sample or a randomized experiment. The data have to be independent also. So we can use the 10% condition if we're sampling without replacement. So those two conditions are actually the exact same. Those are the ones we're used to. A little bit of a change comes in the normality condition. So how is it a little bit different than the one for confidence intervals? Well, when we're conducting hypothesis tests, we always start out like we're trustworthy people, I guess, right? We start out by assuming that the null hypothesis is true. So if you remember the normality condition from before, it was n p hat, n1 minus p hat. Well, if we're assuming that the null is true, we're actually not going to use p hat in this case. We're going to use, we'll call it p naught, p with little subscript 0, not p hat. So p naught refers to the p, the proportion from the null hypothesis here. So we're going to use n p naught and n1 minus p naught. And that's actually the only difference in the conditions. Instead of using p hats here, we're going to start out by assuming that the null is true, so we're just going to use whatever the p from the null hypothesis is. We'll call that p naught, or p sub 0. So that's our large counts condition. Okay, and the next thing we need to talk about is a test statistic. So here's the definition. A test statistic measures how far the sample result, which is the sample data like p hat, so how far the sample result is from the null parameter, which is the p that we get from the null hypothesis. And in what direction, so above or below, and we know that whether it's positive or negative. And this is done on a standardized scale. For example, like a z-score. So that's the definition. That's a really fancy way to say, hey, we need a z-score so we can calculate our p-value. Is it on the formula sheet? The test statistic formula? So it is, sort of, in a sense. So this is what you get on the formula sheet. The formula sheet says test statistic equals your statistic minus parameter, so basically p hat minus this p, divided by the standard deviation of statistic. So that's what you get on the formula sheet. I don't know how helpful that's going to be. That might not be overly helpful to you, but it is there on the formula sheet. So, and just a reminder, what do we use the test statistic for? That's actually just sort of a z-score, or maybe in some cases a t-score. We use it to get a p-value. All right, so let's talk about the 4-step problems here. The 4 steps come from the AP rubric, right? So it's a 4-part grading rubric, so we have to speak to each one of these steps. Hopefully you know these steps by now, right? So we know it's state, plan, do, and conclude. Those are the 4 steps. So let's talk about what we need in each when we're conducting a significance test. So for the state step, That'd be a good place to state what your hypotheses are, right? What's the null hypothesis? What's the alternative hypothesis? Along with stating the hypotheses, you need to define the parameter in context. So whether it's p or mu, you need to say what it is in the context of the problem. And lastly, the one that kids oftentimes forget, you've got to say what the alpha level is. So whether you're going to use 0.05 or 0.01, you have to say what alpha level you're going to use. Typically, it's just 0.05. For the plan step, so we know this is where we have to meet the conditions, but also the graders are going to look for, can you name the type of test that you're going to use? And a lot of times those are in the calculator also. So, for example, in this section we're going to do a one proportion z-test. So, can you name the test and can you provide the conditions for that test? So that's something that's a little bit new, but the graders are definitely going to look for that. Can you name the test that you're going to conduct? And then in the do step, that's where you actually do some stats, right? We crunch some numbers. So two things that you need for that step. You need to calculate the test statistic. In this section, that's just going to be a z-score. And then you need to use that test statistic to get a p-value. So those are the two things. Test statistic and p-value. And then for the conclude step at the last part here, you got to make a decision. Are you going to reject or fail to reject? And you've got to give that in context. So the last part there, and I really probably should have two check marks here. One should be make a decision, check mark, and the other one should say summarize in context. So if you want to receive a 5 on the AP exam, there you go. Full credit for each step along the way. All right, let's talk about the next piece here. What test statistic is used when we're testing for a population proportion? And is it on the formula sheet? Well, we're actually going to use z-scores. Proportions will always use z-scores. So in this case, our test statistic, we'll start with z. And this is going to be a fraction here. So we take our sample data, p hat, and subtract that p naught, the one from the null hypothesis, so whatever that proportion was. And then in the denominator here, we're going to do the square root thing. And there's p's, and there's an n. You'll probably recognize it, but I want to be really careful here. So p, 1 minus p over n. Which p should I use? P hat or p naught? That's the question right now. So if this were a confidence interval, I'd actually just use p hats. But remember, when we start out for significance tests, we assume that the null hypothesis is true. So we're actually going to use p naughts for these. So be careful with that. We want p naught down here. And p naught comes from the null hypothesis. That's just a reminder. This one comes from the null hypothesis. So the null hypothesis will say something like p equals 0.5. Whatever that p is, that's what we're going to use for p naught. And then in the denominator, when we're doing the standard deviation, we use p naught because we always start by assuming that the null is true. All right, so we assume that this p naught will get our standard deviation. Okay, so is this on the formula sheet as it's written? It's actually not. So yeah, a little sad face here. The only thing that's on the formula sheet was that test statistic thing that we looked at earlier. This specific one is not on the formula sheet. Okay, so the last part on this page says what happens when the data, or our evidence, don't support the alternative hypothesis at all. Okay, and what that means is, let me just give you an example. So what if we're given these two hypotheses at the start of the problem? So for the null and the alternative, we have p equals 0.5 for the null. and the alternative we'll say is p is greater than 0.5. So let's say we're given these two hypotheses at the start of a problem, and then either we get the sample data or we're given some sample data and it says p hat is 0.31. Okay, well this p hat really doesn't reflect this alternative hypothesis at all. So if we just cover up this alternative hypothesis for a second, you have the null hypothesis equal to 0.5. If you conduct some sample data, right, you go out into the world and you conduct some sort of research and you get p hat as 0.31, well, then your alternative suggestion should be maybe the true p is less than 0.5, right? So this hypothesis is just off. For us to even begin to use this alternative hypothesis, we'd have to get a p hat, that was above 0.5. So these two don't work together. So if you notice that, like in this case, p hat already doesn't support the alternative. So like we wouldn't even have to go through and conduct the test because we know we would definitely fail to reject the null, right? We don't have any evidence that the true p is greater than 0.5. Heck, we couldn't even get a sample p hat that was above 0.5, right? So why even bother doing the test? Well, what we need to do is fix the alternative hypothesis, right? This data suggests something else. So we need to update the alternative hypothesis. So how do we do that? How do we fix HA? Well, if your p hat is 0.31, you can do one of two things. So that suggests either p is less than 0.5 for the alternative hypothesis, or you could just be more general and just say, I don't know what exactly it is, but I just know it's not equal to 0.5. So either one of those would work, but p greater than 0.5 would not work if your p hat was 0.31. So it's always worth it to make sure your sample data actually supports the alternative hypothesis from the get-go. Alright, so let's look at the one and only example for these notes. It says, according to an article in the San Gabriel Valley Tribune, most people are kissing the right way. That is, according to a study, the majority of couples prefer to tilt their heads to the right when kissing. In the study, a researcher observed a random sample of 124 kissing couples and found that 83 out of 124 of the couples tilted to the right. And if you think about it, both people would have to go to the right for that to work, right? Is this convincing evidence that couples really do prefer to kiss the right way? Okay, so a couple things that jump off the page. 83 out of 124, this came from the hands-on data that was collected. So this would be our p hat, right? Our p hat would be 83 out of 124, which is about 0.669 as a decimal. So the other phrase that you should really start to pick up on in these problems is right here. Is this convincing evidence? So when you see that, that implies that you're supposed to conduct a hypothesis test, right? So is this convincing evidence? I don't know. We're going to find out, right? We're going to conduct a hypothesis test. So once you know you need to conduct a hypothesis test, then you know if you want to get full credit, you want to get a 5, you need 4 parts: state, plan, do, conclude. So let's start with the state step here. So this is our first ever experience with these hypothesis tests. So we need to start with the hypotheses. So we want to test 2 hypotheses, the null and the alternative, right? So we want to test these 2 hypotheses. The null, remember that that's a statement of equality. So maybe 50% right, 50% left. So that would just be p equals 0.5. And then the alternative, well, it looks like maybe more than half of the people kiss the right way, right? So this would be p is greater than 0.5. And then just don't forget to define what p is. Apparently, that's the true proportion of couples that kiss the right way, which means they tilt their head to the right. So the true proportion of couples that kiss the right way. Okay, last but not least, we need to say how picky we're going to be when we're testing these hypotheses. And by that I mean we need to give our significance level, right? We need to know how low our p-value has to be. So we're just going to use the most common one. So we're going to use a significance level of 0.05 for alpha. Okay, so that's good for the state step. We got all 3 points. We got our hypotheses, we defined what P was in context, and we gave the alpha significance level. So next is the plan step. Okay, so what type of inference are we making? What type of test are we going to conduct? So we can always say it this way. If we meet the conditions, right? If conditions are actually met here, we're going to perform a 1 proportion z-test. Actually, we would do it even if the conditions weren't met, right? We would just say proceed with caution. But we're not going to say that at this point. So if conditions are met, we'll perform a 1 proportion z-test. The first condition, randomness, I think it says somewhere in the problem, right? It says a random sample, so we should be good. So the data comes from a random sample, check mark. Next, we've got the independence condition, and we should be well below 10% of the population here, right? So 124 couples, right? That's far less than 10% of all couples. So we can say the 10% condition is definitely met here. Check mark. All right, and then last of the conditions, we've got normality, which usually we say NP greater than 10, N1 minus P greater than 10. It's the same thing here, except don't forget we're going to use this P naught, which just means the P that you used in the null hypothesis. So here that would just be 0.5 for this P. So NP would be 124 times 0.5, which is 62. So that definitely beats 10. Great job. That gets a check mark. And we've got to show the other way. So N1 minus P. So 124 times 0.5, which is 62 again, which is bigger than 10. Great job. So the large counts condition is met, meaning, hallelujah, we're done. We can assume normality. All right, so all 3 conditions are good. I just need a little bit more space here. So we've done the state step, we've done the plan step. It's time for the do step. Only 2 things we need here. We have to start with the test statistic. So we know the formula. We got this earlier in the notes for the z-score. We do p hat minus p naught divided by this square root thing with p naughts in it. So first let's get our test statistic, and then we can take that z-score and use it to get our p-value. Okay, so let's get some numbers in here. We know p hat is 0.669 minus 0.5 for this p naught. And then let's get that square root with 0.5. 1 minus 0.5 is still just 0.5. And then this value should be 3.76, and double check that. Make sure you're able to get this in your calculator, but this should be 3.76 for our z-score here. All right, so now let's use that to get the p-value. And since this is a z-score, I'm going to draw and shade our normal curve. So here's my normal curve. Z-scores have a mean of 0 and a standard deviation of 1. I want to know what's the probability I would get something this high or higher. So 3.76 for my z-score. I'm going to mark it off and then shade everything above it, because I want to know how rare this is, and it seems like it's actually going to be really rare. So 3.76, shade everything above it, and then we can find that probability with our calculator, right? So the normal CDF command. And then just make sure you label your inputs. For example, the lower bound that you would use would be 3.76. That's where we marked it off. The upper bound, technically that goes on forever, so we'll use 1E99. the mean for z-scores here, the standard normal curve, is 0. The standard deviation is 1. Which gives a really, really, really small area of 0.0009. So our p-value is actually really small in this case. We're definitely going to end up rejecting the null hypothesis. So the last order of business we have is to conclude. So we need to make the correct decision, reject or fail to reject, and we need to put that in context. So for us, we're definitely going to reject, and we have to mention why based on our p-value. So we can say because our p-value of 0.0009 is less than alpha equals 0.05, we reject the null hypothesis. Okay, so we haven't used any context yet. We've made the right decision, right? This is definitely way too rare to have happened just by random chance. So what does that mean? Well, we can say we do have convincing evidence, right? So we have convincing evidence basically that supports the alternative hypothesis. So in context, that means we have convincing evidence that the majority of couples, so the majority of all couples, kiss the right way. And the reason I said majority was because if you remember the alternative, it said p is greater than 0.5, so that seems to work here. Alright, so that's our first experience doing a significance test. We've done the state, the plan, the do, conclude. And we also introduced the idea of a test statistic in these notes. So that seems like it's enough for now. I'll see you in class.